Hello creators and makers, this is the Random Engineer. Today we're going to continue with our tutorial series using the Sheetmetal design. So Sheetmetal design is basically designing with, you could say, sheets of any kind of metal. Basically, the operations needed for creating these parts are punching, which is done in a turret, and forming in a turret as well, and finally air bending or any other kind of bending sheet metal process, let's say like that. So other than that, sheet metal design is not, for example, for forming big metal parts, like trying to make pots. Is not the right way of sheet metal design. Is not the right way of trying to design pots and stuff like that. So that's one process that is not taken into account while designing sheet metal, even though it's done in sheet metal sheets. So yeah, just to clarify that before I begin. So to design in SolidWorks using sheet metal, you don't have to do anything. You just have to go into your new part mode and just start going in sheet metal. So if you don't have this tab, you can always right click here and again show and hide your other tabs. So in this case, I'm going to go sheet metal. And then between sheet metal, you have two ways of starting a part. Well, actually three. But I'm going to say, yeah, I'll probably make the three of them. So the first way of making a sheet metal part is creating a profile. So for example, I'm gonna create that shape. As you see, this is not closed, and that's why you have that's known as being a sheet metal profile part. So once you do that, you go to sheet metal and say flange or tab. And as you see, what it's doing, it's creating, it's putting 1 millimeter thickness sheet metal around the profile. You can go on that way or reverse that direction to go outside. And as you see, it's going to create the radiuses automatically, because if physically you will never have a 90-degree bend in a sheet metal part. That's why the process itself is sheet metal and not other kind of process. So that's one way of creating parts. That's profiling, and then also we have creating an actual contour, which is going to be let's say we're going to create a odd shape. As long as it's closed. As you see, it's all closed now. So I'm going to create a flange, and as you see, it's going to fill the material between that region. You can also go one way or the other way. So if I look at it from the front, you can see the difference between those two. So you can control that also. A third way, it's a compared to sheet metal feature, but that's a more advanced way that we're going to also touch on later. So just to start, we're going to create a rectangle, let's say 50 by 50. All right. So yeah, we're going to create that. And as you see, here are your options. Your options are, you can select, you can define the thickness here. You can reverse that direction to say in which part of the region is going to start being created. And then also you have your bend allowance, which can be defined by the bend table, K factor, bend allowance, formulas, bend calculation, etc. Most of the time you use a gauge table, but that's another maybe I do have, okay. So in this case, I have a sample table, which is going to be steel. Oh, let's say aluminum because it's in metric units. So what it's going to do is it's going to create a new part, and it's going to look up into a Excel sheet table, and it's gonna look for K factors. So the K factors will be defined by the bend radius and the sheet metal thickness. And that's why you usually use a gauge table, just because you can define various K factors between the which relate the thickness of the material and the radius of the bend, which is also done in a press machine or stuff like that. That's why you usually have to use gauge tables. If you don't use gauge tables, you can define a K factor. The bad thing about that is that whenever you change your angle or your bend radius, the K factor changes for the same material. So it's not going to be as accurate just by defining a default K factor for all the bends and radiuses. So that's why you usually use a gauge table. So from the gauge table, like I did before, I'm going to select an aluminum one. And from the aluminum one, depending on how your gauge table is set up, you can define different gauges. In this case, I'm going to say let's say 20 gauge 20. And as you see, it's going to tell you that the thickness of the material, in this case, is 0.9. And you can also override the thickness, but if you try to override the thickness, then there's no reason to have a gauge table, so you might as well just keep it like that. Also, you have different radiuses for the bend. So for example, these are just the default ones. So whenever you're designing, you can also change the bend radius, but this is the one that's going to be defaulted as. So in this case, I'm going to choose the 1.5 millimeters, just because I just want to show you that you can do that. So this radius depends on the tool that you're using. So if you have different kind of bees in your punch and die press tool, the radius will be defined by the punch. Yeah, the punch. So as you see, the bend allowance will define how much the material can bend before giving you an error, and that's going to be defined by your K factor, which is also related to your gauge table. So that's, as you can see, it's really important to have your gauge table very well defined. And usually it's quite difficult to find a gauge table that suits all the materials, just because some operators use different methods when bending the sheets, and then depending on the batch of the sheet metal that you buy, you'll get different. Even though you can say I want this kind of aluminum, you'll get the same kind of aluminum. You'll buy the same thing in paper, but mechanically the properties are going to be slightly different, and it's always recommendable that you create your own gauge tables depending on your own machines and operators and suppliers. So that's why there's no like a general gauge table that anyone can use. Obviously, someone's tried to do that, and it works on most of them, but not for all of us. So that's something that you have to take into account also. And then also you have here an auto relief. Auto relief, it's just the way that it's gonna be. So when you make a bend that is inside a sheet metal part, you obviously need a relief, otherwise you will never be able to achieve that bend. So in this case, the default relief will be rectangular. You can tear it, which means that when you try to do it, when you try to do the bend, it's just gonna rip the material. And the up round is just another shape. And I'm gonna say rectangular for now because it's an easier one, and you usually have that in your turret tools. And yeah, that's all. I believe that's all that's probably all the options you've got from this closed region shape. So as you see, I'm going to click on OK, and it's going to look up all the tables and everything, and it's going to create a 0.9 millimeter thickness sheet with the dimensions that I gave him before. So once you do that, I'm gonna show you what I mean by the relief. Sorry. So as you see, we've created 3 features. First feature is the sheet metal feature, which has all the information about the sheet metal. In this case, the gauge table, the thickness, the bend radius, K factor, and in this case, I'm gonna choose the bend allowance to be the gauge table, bend table. There you go, and you can choose the bend table here. So in this case, I'm gonna click on sample and auto relief and stuff like that, right? So yeah, that's your sheet metal feature, and you can also save as your new gauge table if you choose to create one. Also, we've got a base flange feature, which contains a sketch, and the only thing that you can change from here is the thickness itself, or reverse the direction of the orientation of the part. So if you want to override this, as you see, it gives you the chance to override the radius, but not anything else. If you already decide to change your thickness here, you'll have to change your gauge table if you select use the gauge table. Otherwise, you'll need to change it from here. So that's pretty much. Oh yeah, I almost forgot about flat pattern. So obviously, whenever you are using a designing a sheet metal, you always need to create a flat pattern, because from that pattern you're going to get the actual plank, and that plank will be folded so you can achieve your ultimate shape that we're going to design now. So for example, right now I'm going to create a bend and an edge flange, sorry. So what that's going to do is just going to create a bend, and it's going to extend that bend up to a certain up to a certain dimension that you define here. We'll go over all this in a little bit, but I want to show you the flat pattern. So as you see, we've got that shape now. So if we want to achieve that shape, let me just define this as a complete number. So if we've got a 20 mil bend and a 50 by 50 square, when we flatten this, we'll get that shape. So this is ultimately what you have to give your turret operator or supplier for sheet metal. You have to give them this shape. This shape is the one that they're going to use to turret it out using probably a turret software, or yeah, it's going to be a turret software. And that's what they are going to be using to create your part. And then these lines are the, well, as you see, the outside lines define your outside overall dimension. In this case, since it's a square, it's going to be the same. And this is your bend line. So this tells the machine where to position the tool so it bends it. But that's usually, well, that really depends on the kind of bending machine that you've got. If you've got an automated one, that bend line will be useful, because that you can program it from the DXF from your flat pattern. If you have an operator, you probably don't need it, and in the drawings anyway. So that's what flat pattern does. So one important thing that you should note with the flatten feature is that when you click on flatten, you'll get this. As you see, this gets unsuppressed, and when I unclick this, this gets suppressed. What that tells you is that this is in a different configuration. So that means if I create, let's say, a cut here, I'm gonna make a cut. If I make a cut here, you see that the feature comes before the flat pattern. But if I say flatten and create a cut, you'll see sorry, let me just get the cut really quick. There you go. So as you see, the cut now is done after the flat pattern, and there's actually a huge difference between those two. So when you unflatten the part, that is telling us that the end shape will be like that, right? And but when we flatten the part, as I told you before, this is the manufacturer's information, so this is what they will get. But if this is what you wanted, then you have to be careful where to put the features. There's actually a good reason why some features should be after this, and other cases that are really good to have it before it. So you just have to be mindful of that. I'll show you what I mean when the time comes. So I'm just gonna delete this and unflatten because I'm still editing my part. And now that we created this, I'm just gonna delete it again to explain you better what's the flange, edge flange. So basically the edge flange is a, like you said, like you saw before, it's a flange that's gonna be bent in a certain angle for a certain length. So actually you can change the direction here. What you do is click on the one edge, because it's an edge flange, and it will ask you for that direction. And as you see, you can just click on one side or click on the other side, and that will give you the default direction, but you can always change it back to using this one. So the first options that we get is flange parameters. With those, it's just asking you for flanges, sorry, for edges. So as you see, you can select different edges, and it will create the same flange for all of them. Also, you get an edit flange profile, but that's a little bit, well, it's very useful, but I'm not gonna tell it, explain it in this tutorial, maybe probably in the next one. So right now I'm just, let's just say it like this. So as you see, you can use the default radius, which is going to be defined again by your punch in your press brake tool. And as you see, it's going to create a 1.5 radius bend there. You can override that if you want to change to a different tool, and you can override that. For example, if it's a narrower angle, you will probably use a smaller V, which is going to give you a small radius. So that's what you change here. Also, you have here the gap distance. That's when you have two edges. Let's see here. As you see, this can be defined as a weld gap if you want. As you see, when I extend this, you'll get a bigger gap, so that your welder can use a 2.6 millimeter wire and try to weld that. Obviously, that's too much. So that's how you define your weld gap. One way of defining your weld gap, at least. And obviously you can define your angle here. There you go. So from here you can select, I want that angle, and obviously if you select another line, it's gonna give it the same angle as you define. So you have to be careful in the way that you define your edge flanges, because the same shape will be defined for all of them, and if you want to change one individually, you wouldn't be able to do it. At least with one feature, you need to create different features for each flange, and then you can do it like that. So in this case, we're going to stick with that one. And then you can also define a perpendicular to a face or parallel to a face. well, this is just going to, you can define an angle or say that you want it parallel to a face, because if you have another face anywhere in your design, you can use that as a reference, because you won't always get complete degrees. You'll sometimes get like 65.458 on, and you're not going to be changing this until you actually get the right angle. So it's better just to say perpendicular or parallel to a face, and that will give it the correct orientation automatically for you. So that's why this option is available for you. So if you go back to your features and remember what we did in one of the first tutorials, the extruded boss base had these options here. Obviously we have less options, but the ones we have here work the same way. So blind is something that you can define. Here you change the direction of the angle. Then you have up to vertex, so if you have like a closed shape, oops, let me just do it like that. Okay, cool. So if you can imagine and follow my mouse, and you have a closed shape here, you can define that this face will extend up to one of the vertex that you select, and then up to edge and merge is basically, it's gonna ask you for an edge, and it's gonna merge those two and create an automatic radius for you. So that's something else that you can do. So in this case, let me just see something here. There you go. So you have, for the flange length, you have 3 options down here. Oops, I keep clicking on that. It's 20. So I'm gonna say outer virtual sharp. So I'm gonna click OK, and as you see, I defined it as 20. And I'm going to just create a sketch so you can see better what I mean on that face, and I'm gonna say 20. So if you drag this over here, as you see, the 20 starts from the let me just get the correct definition. Virtual edge, I think. The outer virtual sharp. So it's gonna extend this. It's gonna create a virtual line which is going to be extended infinitely, and it's going to do the same for the other side. And the point where they intersect is going to be the starting point from the dimension. So that's why it's being done as 20 from that imaginary point to the edge flange. So that's one way of defining it. Also, is the inner virtual sharp, and as you see, now our 20 mils, it's been defined by that one, and that's what's gonna do is let me just see the image here a little bit. I thought it was gonna be from the other way. Okay, I think I know what's going on. Yeah. So as you see, instead of extending this line from the outer part of sheet metal, it's going to do it from the inner part, and from there it's going to create our extended line, and we're going to get a different position for our imaginary point there. So that's why it's going to be the 20 mils will be defined from that imaginary point to the farthest part of the flange. And finally, you'll have the tangent bend, which is in this case is going to be the same as the outer virtual shape, just because we have that right angle. And let's say we make a shorter, a narrower angle. And as you see, it's going to be creating the same point there. I'm going to say that I'm just going to define my sketch back again so you know what I mean. And as you see, those 20 mil will be defined from the outer virtual edge to the side. And if you do it the other way, the parts will be defined from the, let me just give it a little bit here. There we go. I'm gonna delete this relationship and say these two have to be tangent and measure the angle right here. Obviously, in this case, it's gonna be 90 because that's the way the feature works. So as you see, it's extending, well, it's creating an imaginary line from there, but instead of meeting it in the point where the other part starts, it's gonna start creating a, it's gonna keep extending until you get a 90-degree angle from the tangent edge of the bend. So that's another way of defining those 20 millimeters. So you have to be mindful of the way that you are designing this, just and then you can see that what's the difference between these three, and these really have to be taken into account whenever you want a perfect design. And even if you don't, you have to be careful about how you define your parts completely, because if you want to edit this and you were meant to have the dimension from this edge to that edge instead of from the outer auxiliary line, you will probably measure in your assembly fit 20, but once you define this as 20, you'll see that they will not meet, and that's just because of the way that you've defined your parts. So that's something you have to take into account. So I'm gonna go back to 90 here. Keep it like that because I like the way that the point that it starts. And here you can change the flange position. The flange position is basically where this line starts. So as you see, we defined our square in 50 by 50. And if I show it, it's not edited, show it, there you go. If I measure from there to there, it's gonna be 50 mils. And as you see, it's inside our defined square. Now, if I change this and say from the material outside, it's obviously going to be defined from the material outside. And if I do this, I'm going to be shown the squares, that one, and you see the material is on the outside. So if I measure from there to there, it's going to be 50 mil down here. And if I go from there to the outside, it's going to be 50 plus 0.9, which is the thickness. There you go, it's 50.9. So that's another way of defining your flange. Also, you have from the outer edge, which is going to be from there, and from the start of the bend to the other line, it's going to be 50. But from there to there, it's going to be a weird number. Well, it's not going to be a weird number, it's going to be a number which will be the, so it will be the radius plus the material. So in this case the material is 0.9 and the radius was 1.5, I believe. Yes, 1.5. So 1.5 plus 0.9 is 2.4 plus 50, that's going to be your 52.4 right there. So as you see, even though it may look like a strange number, it's actually a calculated one. There is a bend from the virtual sharp. In the same way that we created this virtual sharp, we change this. The virtual sharp will be propagated from that line is going to start the bend. So that's why you see how the bend changes here. And finally, tangent to bend is the same as here, tangent bend. It's going to create the two lines, a perpendicular line to the tangent edge of this, and it's going to start from there. So as you see, the position where that where the bend starts depends on those. And obviously, you can also change that. So for I don't know if it's for all of them, but for most of them, yeah, there you go. For that one, you cannot. But for that one, you can offset them. So if you say, okay, I wanted 10 millimeters from the edge. So let me just do that and say, okay, I want it from the outer edge. The bend is going to start there, but I want to offset it 10 mil. And then we'll get the same number as we did before. So from there to there, it's going to be 10 mil, I think. Oh, there, sorry. From there to there, it's going to be 10 mil. 10 mil in X. There you go. So that's what it's going to do. So that's an easy way of defining flanges and sheet metal design parts. And trimming, it's when, I believe, when you have two edges, we just get rid of the offset. I'll have to come back with you on that one. I haven't really used this one much. Maybe see here. No. Okay, never mind. All right, so we're gonna say we want it from there, and as we said before, just one edge. Yep. And the custom bend allowance is just a different way to use a different K factor for that bend, and I'm going to explain the K factor in depth with SolidWorks probably the next tutorial, because that's a big subject actually. And custom relief type is the same. It's going to allow you to make a different relief for those. So now we're going to talk about reliefs actually. So I will now, yeah, I'm going to do that. I'm going to delete this also. I'm going to hide the other one. And what I'm going to do now is, okay, I'm going to create another flange. And this time I'm going to edit the profile. You can click on here, but I usually don't like to do that. So sorry, I'm just going to define it and say 20 just for now. And okay, let's do that. Oh, sorry, let me just go out from here. There you go. Okay, so we've got that shape, right? If you go and open the part, you'll see that there's a sketch here, and if you edit it, you can do it. Another way of doing this is clicking there and edit the flange profile, but like I said, it's just my way. I don't like to do that, but you can do it. Just because I don't like that little pop-up window that tells you that the sketch is correct or not. So as you see, the way that it's going to define the sketch is going to be copying that edge and, sorry, just converting the entity on that edge. And when you delete this, you will be able to make any shape you want. Obviously, this edge and this edge have to be in the same, they have to be collinear, otherwise it won't work. So if I do that, let me just define this 10 mil. Oops, not too much. There you go. And let's define this as, okay, let's say 10 here. Yeah. So now I've done that, and as you see, the flange is now that shape, just the shape that I created before. And as you see, I can still edit this without any problems, I think. No, seems like we can't. Yeah. Never mind, I thought I was going to be able to. That's weird. Let me just play a little bit, see what can be done. Okay, now it can be done for some reason. So as you see the sketch, I didn't define the length here, because if I did, that length will be defined by the new dimension that I just created instead of being defined by this feature. And that can give you some problems in the future too, when you have when you try to edit one dimension and nothing changes. It's just because of that, and then the software will bug and you'll have issues. So just be mindful about that. So also, you don't have to create a rectangle or a square. You can select pretty much any shape that you want, as long as it's a closed one, obviously, and it's a complete contour with no you can have construction lines if you want for reference, but nothing else. So if I get rid of that, as you see, I will still define this just because I need to. Yeah, there you go. So one way to know if your sketch is okay is by defining it and then dragging the line, and if you see that only the length changes, you've successfully defined it. So let me try again. If I drag this, there you go. Oops, not that one. Where's the other one? Let me edit this. Let's see what it lets me do. Yeah, as you see, I edited it too much, which is not a problem actually, but that just means that you have to define it like that. So in this case, it's having issues just because it has too many dimensions. Otherwise, you would be able to define it. But that's just another way of doing it. SolidWorks recognizes that you want to edit the flange, and it tells you, okay, I'm not gonna mess around with what you try to do. So it lets you define it completely, so you don't have any issues. Now you can see that. And if you have the blind, you see you cannot define it anymore because you've actually broken that link. But no worries, because your sketch has the information there, so you can only change that now. So that's one way of defining a flange. All right, so as I said before, I'm gonna be talking about tearings, not reliefs. Yeah. So in this case, just check. There you go. So as I said before, the flange position is going to be where this when this part starts, and what happens if you start from the inside. I'm gonna do that now, and as you see, the relief, it's rectangular. So if I accept this, it makes an automatic rectangle. And as you see, this is 0.9 millimeters, and this is obviously going to be this is 0.9 millimeters as well. And if you remember, this is the thickness of the material right here. And if you want to define that, oops, let me just go check. Yeah, if you want to define that, you cannot say I want this as 1 mil and the other one as 5 mil. You'll have to give it a relief ratio. So if I give it 0.5, let's say, as you see, this now is 0.45, which is half of 0.5. Oh, sorry, 0.9, and this is the same, half of 0.9. So that's what the relief ratio does. If you unclick this one, it would allow you to edit the width and the depth. So in this case, I'm gonna say 10. Oh, sorry, too much. That's the width. I'm gonna say 1, and this will be 10. There you go. And as you see, we've got that shape. So that's what we mean by relief. Relief is just a cut so that the bend is easier for the machine. Because imagine if this wasn't if there weren't a relief there, you can, let's say, I'm going to show you as tear. Okay, if you go tear, as you see, there's no relief at all, and the material has just ripped. And if you try to do this in the real world, it's just going to give you very bad results, especially with a flange like this. I mean, there are certain times you must do this, but it's not recommendable at all, because you cannot expect this to be a straight line if you are tearing the material. So you'll have to do a post-processing of this if you want to achieve something like that. And you can also define the way of the tear. So in this case it's ripping, and this case is extending. If you extend it, well, in this case it's not going to create it. Just because this has an edge here, and that would mean that this shape will have to change. So okay, I'm gonna leave it like that for now. I'm gonna create another one just to show you what the tear is. I'm gonna do that, edit the flange with the other way, and as I said, there's a pop-up here that you have to change, and it's always a good practice to have this as a I don't remember what I was going to say. So it's always a good idea to have the sketch normal to the drawing. Otherwise, if you're going from there, you'll think you'll be able to see what you're trying to do, but in reality, you won't. Trust me, I've done that. I've tried to do it, and it's very confusing sometimes. There you go, I can now finalize it, and we're done. And now, as you see, since I created the bend from there, we've got that relief. So I'm going to use a custom one and a tear with an extension. Let's see if it lets me do it now. There you go. So this is a more realistic representation of a trying to tear a material. What will really happen is the material is going to be dragged by this face, and that drag is going to get extended as probably much as this. Obviously not that, because they're just going to break after a while, but like I said, it's a more realistic representation of what you're trying to do. So yeah, like I said before, rectangular kind of relief is one of the best practices, at least. Okay, and just to finish this tutorial, I'm gonna talk about the up round. Up round is basically going to be that one. It's gonna create a tangent circle there. which is going to be the same radius as your relief. In this case, it's 0.5 ratio relief, so it's going to be half of the thickness, which is going to be 0.5. And that's a little cute ramp. And if you have the tooling and you want to do it, it's great, but it's not always useful. Well, it really depends on the operator and the shape that you actually want and the finish, because that looks better than a cut. And if you wrap your finger around there, you will probably won't cut yourself, at least in that relief. While on the other one, you may get scratches. You won't cut, obviously, but you'll get scratches at least. So if you get the opportunity, and now and the operators won't get mad at you just because you want that shape, that's perfect. But if you want to save some money and some time for the press to change the tooling, and just because you want that shape, then it's not worth it. So that's gonna be it for today. I really hope you guys like this video. I tried my best to explain it the best I could. So just as an overview, we did flanges, base flanges, and the two ways of defining a base flange, and all the operations in the edge flange between. Oh yeah, we went over all pretty much. So like I said last time, we're going to next time we're going to be designing. I'm gonna be explaining the K factors, and probably I will explain also the convert to sheet metal feature. After we're done with that, it's time to go over these shapes and probably all that. So like I said before, thank you for watching this video. I hope you guys like it and find this information useful. And just to leave you, I'm gonna flatten this and you can see the end result. Okay guys, I hope you like it. See you next time. Thank you for watching. If you like this video, make sure to like it and share it. Subscribe and follow me on social media to know when I'm live. And if you want to support this channel, click on the Patreon button. See you in the next design.